Hi, I'm going to talk about limits and why we need limits and how can we enforce limits. Before that, a little bit about myself. I'm a principal software engineer with RedHat. I'm part of the technical partner engagement team where we help companies bring up their products into our platform specifically for the telco market. I've been working with Kubernetes long time before I joined RedHat. So it's been quite a while. So will we let our kid decide how much candy he wants? We probably will not let them do that, although they will be very happy about it, but we will not. We are, as the kids administrator, responsible for them not getting into trouble. So what about applications? Here we have our kid, our developer. He or she wants to get as much candy as they can. We offer this seemingly limitless resource pool in the cloud. Why should they set up limits? The problem is that if we let developers take all the resources, in particular in restricted environments where the resources are shared between the applications and the control plane, we may get into trouble. So as cluster administrators, we may have a very hard time because if we rely on developers to set up limits, they may not do it, and it may break the cluster. What could go wrong? First, let me give you a little bit of background. As part of my job, I got our task of validating. We do some, for our customers, we do capacity planning depending on the size of the cluster and the size of the machines. We reserve some resources for the system. This is so the control plane runs properly. We have tools to validate that if we put load on the control plane, it works within the number that we reserve, but we wanted to see what happens when we, in restricted environments, and what we mean by restricted environments, this is targeted to the edge clusters where we may have a cluster of one node. You may say that's not a cluster, but yes, we're running Kubernetes on one node to 3 nodes. What characterizes these clusters is that the control plane obviously is sharing resources with the applications. So in this type of clusters, we wanted to see what happens when applications go wild. So first thing I did, I took a load generation tool, StressNG, that is a very good tool to put a lot of load on your systems. It's known that if you run it with a particular set of parameters, you will break your system. And that's basically what happened. I broke my cluster to the point where if I didn't have etcd backups, I had to just reinstall the cluster. There was no way of just getting it back. Even if I stop the cluster and restart it, it has memory of what were the loads running before it stopped, so it will run them again and go into the same problem. Only with a proper backup, you will be able to restart it. And without a backup, you just need to reinstall. So that was no good. So I designed this application that will let me to generate load or application load on the cluster, but have control of the load from outside the cluster. So I went and designed a simple web application. What it does, it generates fractals. This is good because the bigger the fractal, the more memory and the more CPU I'm using. So I can very easily, through the URL, control how much load is put on the application and on the cluster. So I went to my cluster and I deploy the fractal generator. I put some horizontal pod autoscalers, and when there are many requests, of course, we're going to get more and more and more pods. And some of these pods are going to be doing big fractals. Some of these pods are going to be doing small fractals. I have a utility that basically generates many, many requests in parallel. And here we see at the top, I have, I'm running an infinite loop that in parallel gets 400 requests of 512 by 512 fractal. This is a relatively small one. And this was done to generate network traffic and cause the auto scaler to put more and more pods. At the bottom, we see we have 200 parallel requests for a big fractal. This is the one that is using memory and CPU. These are floating point operations, so it's kind of heavy. I ran this for a while, and then, as expected from my previous test, that the cluster broke. So, as you can see, I lost control, both from the UI, but I also lost control on the command line. That's what you see here in the middle. The good thing about this approach, the application, as you can see at the bottom, the application also became unresponsive. So it's not only that I broke the control plane, the application at one point also breaks. The good thing about this one is that I could stop the infinite loops, let the cluster rest a little, and it recovers. So it lets me analyze what's going on. The first thing I went to analyze is what's happening to the CPU, because that was what was my original task, to see what happens with the reserve CPUs, whether they're enough. What we see here at the bottom is the system CPUs, and I believe the blue is the application CPUs, and then the other line is the aggregation. I don't see that it goes above the limit, but still breaks. So I went further and looked into what's happening to the memory. And this is what is breaking the system. When the application starts using more and more memory and it reaches near the end of what's available, the system just breaks and totally stops working. What we see here is these are the times where the system was down. I stop the application, so it recovers, and then it goes back. I restarted the loops. As we did with our kid, that we didn't let her eat all the candy, as cluster administrators, we can enforce developers to set up limits to stop something like this happening. And we do this through the resource quota Kubernetes resource. This is a resource that basically lets us define per namespace how much resources all the applications running in that namespace can use. Not only it lets us limit the applications, it enforces the developers to set up limits. If you try to deploy something without limits in your YAML, in a namespace that has a resource quota, it will just not accept it. You need to specify limits. This is what happens when I run it with the resource quotas. It goes up, it stops because I stopped the infinite loop. What's interesting is what's happening with the memory. What we see here is that it goes up to a point, then it goes down, probably because the system is just buffering the request and the auto-scaler, but it never breaks. It's always in control.
Are you using system reserve for Kubernetes?
System reserve?
Yeah, for Kubernetes.
We have reservation for the system. We use something we call machine configuration. It's the mechanism that we have in OpenShift to control the reservation. But okay. So if we go back to our original question, the application developer will see some degradation, but the application will keep working, and the cluster administrator, as a good Tel Avivian, will go to the beach. You can read more about the whole experiment in a blog that I published a few months ago, and I'm available for questions. Thank you.